we're gonna do here is perform a preventative maintenance. We're gonna check pressures, amperage on the compressor, capacitor, contactor, make sure everything's good. That way they're ready for the summer. But that's what preventative maintenance is for, to check the cooling components, the pressure. Superheat, subcool is very important when you're checking pressures. Also static, the airflow, make sure that's right. You have to make sure that the airflow is correct before you even start looking at your pressures, because if you have bad airflow, then it's going to throw everything else out of whack. Yeah, so right now what I'm going to do is I'm going to hook up my pressures and see how the cooling pressures look. I was actually here in November to do a winter PM, and it's funny because during a winter PM you're checking heating, but after I ran the heat for so long, the house got hot, so I put it in cooling. And when I put it in cooling, I could hear from in the garage, from where the furnace is at, the line set, the copper line set, it started sounding crazy. So I went out to the condenser as fast as I could, and then I found the compressor sounded crazy. So before I could hook my probes on there to check pressures, the compressor turned off, and I was like, dang, what the heck's happening? So I went to go get my meter and my megometer, and we found that the compressor was locked. On a heating PM, it's important to actually have preventative maintenance, especially for the summer. Let's go check it out. Dang, that thing looks still brand new and shiny. Sometimes I like to run some nitrogen, that way I can clean this up with the brush. This guy right here is a meter. I'm able to check voltage, amperage, very useful in ohms of resistance. I'm able to check compressors, fan motors, just motors in general to see if the resistance, their windings are good. And also I can check microfarads on the capacitor, my ohms across the contactor coil. Like for example, right now what I can check is, am I getting voltage? I am. 240. And then once the contactor gets energized by the thermostat, this will press in and it'll start the system. LYNK UP. I'm able to use what the company made, AI, and I could hook up my tools. I could have AI help me out with the troubleshooting. I could ask it questions, or I can go to the specialist, which is like our tech support, the guy that we have down up in the office. So he'll be able to see what I'm seeing. And the cool thing is, I'll have my hands free. I'll be able to hook up my tools. That way they can see my voltage readings, my pressures, and all that stuff. It's better than FaceTime. You would be able to FaceTime and show them, but with this, you could actually show them what you're looking at, your tools, send them the data tag of the unit. That way they can pull up the manuals. Very helpful. Very, very helpful. Now let's turn on the unit and start checking these pressures. Let's see how it looks with this temperature, outside air temperature. Heat transfer, so you're grabbing heat from inside the house and transferring it outside, but since it's a little cool right now, it's much harder to do that. So when the temperature outside is hotter, you get accurate readings. There's the blower. Low head pressure, low suction. Let's see what my ambient air temperature is. 63 degrees, so we're really close to 50. So it's very hard to see how our cooling pressures are gonna look. That way we can actually determine whether there's issues. We can install, there's something called head pressure controllers, and what that is you can run cooling when the ambient air temperature is much cooler, and you're able to control the condenser fan speed. That way it'll slow up and down, so you can control that head pressure, kind of tricking the system to thinking it's a little hot outside. So that's also very useful, but you don't really see it in residential, you see it more in commercial. 80 times 2652 and divide that by the volts. So not bad on the microfarads under load. Now let's check the fan. Times 2652, divide that by 240.8, 6.3 microfarads. Good number as well. So I'm checking the capacitor under load. That way I have the proper microfarads. That way the condenser fan motor and the compressor have the boost they need. I'm also gonna change this little bracket. I don't really like it. It's a little flimsy. I went to a trade school, but I mean, you mainly learn everything out on the field, to be honest. You'll learn the basics, but you learn everything out on the field. That's how you get the most experience. My pressures look a little wonky, but I want to say it's because of, I mean, we're almost at 50 degrees ambient air temperature, so it's a little hard to discern and to really judge this unit. But I know that when I replaced the compressor and I charged this thing up back in November, when I want to say the ambient air temperature was like in like the 80s, I left this thing running pretty good. Let's get some split temperatures up in that house. Yeah, that's just a supplier temperature, and that's the return down there. So I'm able to check to see the delta T is what we call it. We're at a 15.8 degree split. So 16 degree split, that's a typical number you want to see. So far, so good. So the compressor is pretty quiet, but when I was here that one time and the compressor was acting crazy, it was like, and then the copper line set was kind of knocking a little bit. And then before I could put my pressures on, or my probes on to check pressures, the thing turned off, it overheated, and then it locked up. And we were able to swap that compressor out and have it running and charged within 5 hours of when I found it. Pretty fast. Within the hour, I was able to braze the compressor in and then pressure tested it and then pulled a vacuum. I think I want to say my micron dropped to like below 300. And then I did a decay test for less than an hour. They rose to 600. I did another vacuum and got it down, and then I charged up. But I was really happy that day with the job I did. This is just a filter. He said he just changed it, but I want to double check and make sure. Because sometimes, I'm not saying he does, but sometimes people are like, yeah, I just changed it. And it was like 5-6 months ago. And they're like super dirty. But the filters are very important. Very important. Even though it doesn't seem like it, they're very important. I recommend changing them every month, to be honest. The reason why the filters are very important is because you have a blower constantly blowing air, and like a fan. Let's say you have a fan in your room and you have it running, you start to see dust or whatsoever collect on the fan blades. The same thing happens here. You'll have dust, but the filter catches it. And in this case, in the furnace, the evaporator coil is upstream, and if you don't have a filter, all the dust is going to collect in the evaporator coil. It'll cause airflow restriction. That thing could freeze, and the only way to properly clean it is to take it out. But it's a process. You'll have to pump down the refrigerant, take the flue pipe out. You can either cut the line set or sweat it out, and then you'll have to take the panel off, remove the PVC, slide the coil out, wash it outside, and then put it back, braze it, put everything back together, pressure test, vacuum. So that takes like, sometimes it could take 2-4 hours, depending on the situation. Sometimes it could take more. So it's a long process. So that's why filters are very important. This right here is just the furnace part. This is the heating section. And then in here you have the blower and the control board. But since this is a furnace, this is the evaporator coil, and it's separate. Like in California where I'm from, the weather's so perfect, they don't have air conditioning. So you'll only see just the furnace and then the ductwork. But here, you have the furnace and then the evaporator coil. So this is what's actually cooling right here. It'll absorb the heat from inside the house onto the evaporator coil, since heat moves to cold. So the hot air going from the house, going across the coil, gets absorbed. It transfers it through the line set to the outside unit. And then, I mean, in this case, it's not, the ambient air temperature is cool. So when it's hotter, the hot air gets rejected outside, and that's how cooling works. It's just a heat transfer. You're pretty much absorbing the hot air from inside and rejecting it outside. On the furnaces, you have a safety switch, and if this is pressed in, it'll turn on. But since I took the panel off, it turns off the power in here. This is where your blower is right here. And it says plus or minus 6%, so we're in that range still. So this guy is still good. Looks like it was just recently installed some time ago. I remember back when I was in trade school, I used to look at these units and I was like, what the heck is all this? And I remember I used to have a piece of paper and a diagram labeling parts, but now it's so much easier. I remember I used to tell myself, how am I gonna learn all this? And now I'm doing way crazier stuff. Preventative maintenance is to prevent any issues happening during the summer. You know, it could be 190 degrees, and let's say the capacitor goes out, and you know, you have to call us. We come out here, let's say it's a Sunday in the afternoon and 100 degrees outside. You get here, the house is 80. We check all this before the summer. That way you're good to go. That's what we're here for.